Hi, in this tutorial we are going to solve a question related to molecular orbitals. The question asks, draw molecular orbital diagram for nitrogen molecule. In order to solve this question, first of all we need to write electron configuration of nitrogen atom. Nitrogen atomic number 7 has the following electron configuration: 1s2, 2s2, and 2p3. And if you want to write orbital box notation for nitrogen, one box for 1s orbital, one box for 2s orbital, and three boxes for 2p orbitals, and we have to place the electrons: 2 for 1s, 2 for 2s, and 3 electrons for 2p orbitals, one by one, with the same spin. According to molecular orbital theory, atomic orbitals combine mathematically to form molecular orbitals. The same or similar type of energies of orbitals can come together. For example, if 1s orbital of one nitrogen atom combines 1s orbital of another nitrogen atom, they can form two types of molecular orbitals. One is bonding molecular orbital, and the second is anti-bonding molecular orbital. Let's write here two columns for atomic orbitals. Let's start from here. This is 1s orbital of one of the nitrogen atom, and this is 1s orbital of the second nitrogen atom. And if we combine mathematically them, we can form two types of molecular orbitals. One is anti-bonding, the other one is bonding, and bonding is shown as sigma 1s, and anti-bonding is sigma star 1s. So we know that 1s orbital has 2 electrons in one of the nitrogen atoms, and so if we mix 1s 1s, we will have 4 electrons, and 4 electrons have to be distributed to new molecular orbitals: 2 to bonding molecular orbital, 2 to anti-bonding sigma 1s molecular orbital. Then we can mix 2s orbitals together. Here we can write 2s orbital of this nitrogen and 2s of the other nitrogen, and we know that these atomic orbitals contains 2 electrons. Similarly, if we mix them, we are going to create a bonding molecular orbital and anti-bonding molecular orbital. This is sigma 2s star. This is sigma 2s, and similarly we have 4 electrons in these molecular orbitals. Then at last we need to mix 2p orbitals for both nitrogen atoms. I'm going to draw it here. So 3 of the 2p orbitals of this nitrogen and 3 of the 2p orbitals of the other nitrogen, and we know that each 2p contains singly occupied orbitals. And if we mix 2p orbitals, the first molecular orbital we are going to generate is 2p 1, 2, and here pi bonding molecular orbital, the first one, and the second one is sigma bonding molecular orbital 2p, and we will similarly generate pi star and sigma star. So we need to write here these are sigma stars, and this is pi star, and we have 3 and 3 6 electrons, and we have to distribute 6 electrons to these molecular orbitals, and 2 pairs for pi molecular orbitals and 2 for the sigma bonding molecular orbital. These are because of 2p 2p, we have to write 2p and 2p. So these are molecular orbitals for nitrogen molecule. If we would like to visualize them, how they will look like in 3D, for that purpose we can open a model for nitrogen molecule, and this model shows that we have a triple bond and 2 nitrogen atoms shown with blue spheres or blue balls, and So here we are going to see some molecular orbitals for nitrogen atom. The first molecular orbital that we are seeing on the screen is sigma bonding molecular orbitals as a result of overlap of 2s orbital of this nitrogen and 2s orbital of that other nitrogen. We are forming a sigma bonding molecular orbital as a result of overlap of 2s orbitals. And the second molecular orbital is sigma star, meaning that this is an anti-bonding sigma molecular orbital. As you can see that we have different colors for orbital overlaps. This is, we can say that, negative region of wave function. This is the positive region of wave function for the s orbitals, and we have here a clearly node in between two nuclei. So definitely this is a sigma anti-bonding molecular orbital. The next one is pi molecular orbital as a result of 2p here in this nitrogen and 2p orbital of that nitrogen overlapping with the same algebraic signs of their wave functions and creating pi molecular bonding pi molecular orbitals. Another pi bonding molecular orbital, and this is sigma bonding molecular orbital as a result of overlapping of 2p orbital of this nitrogen and 2p orbital of that nitrogen along their nuclei axis. And we can show here an anti-bonding molecular orbital. This is called pi star or pi anti-bonding molecular orbital because positive and negative wave functions are all overlapping, and actually they are creating a node in between two nuclei, meaning that we have an anti-bonding molecular orbital. Thank you so much.